Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. And today we are going to discuss about circular queue using arrays. Let us see the overview of the course. In the previous session, we have discussed about what is linear queue and what are types of it. And we have discussed how we are going to implement the linear queues also. In this session, we are going to discuss about why we need to go for the circular queues. Why we need to go for the circular queues? For that, you are going to have some disadvantages of a linear queue is there, right? Then, we will be seeing about the applications of linear queue. First, we will see about the applications of linear queue. Then, we will go for the disadvantages of a linear queue. Then, why we need to go for the circular queue, right? In that, we will see what is the definition of circular queue, followed by circular queue ADT. We will be seeing about what are the different data and operations to be performed on circular queue, right? All these things we will be discussing in this session, okay? And we will see about what are the applications of linear queue. Here, the linear queue is going to be used in servicing request on single shared resources like a printer, CPU, task scheduling, etc. Let us take one example here. Here we have 4 different systems are connected to a single printer, right? You consider these are the systems 1, 2, 3 and 4. Now, the 4th system wants to take the print. That means the request given from the 4th system is first, and the 2nd system wants to take the print next, right? That means now this 4 is given the first, 4 is given the first request and 2 is given the second request, right? So that based on the request given to the printer, you can able to get the printouts. And here the sharing is happening between the systems. If the sharing is happening based on the first in first come, first in first out service only, the service will be provided by the printer. This is one of the application where we can see in the linear queue. And the second application is, this may be seeing in your real life scenario every day, right? In a real life scenario, call center phone systems uses queue to hold people calling them in an order. If you are going to call to some customer service like HDFC customer service or any Kotak, any banking systems or any other customer services or Amazon or Flipkart, any of the services if you are going to call, if the call center person is free, then he is going to pick up the call. Otherwise, he will be putting you in hold, right? Until that service person is free, right? Until the service representative is free, he will be putting you in hold. This is also following the queue procedure, right? And the next one is, that is in breadth first search also. This is one of the graph traversal technique. There also we are going to follow the technique of same application of queue. In this, this BFS is used to find an element from a graph. By using this method or searching technique, it is going to find whether an element is present in the graph or not. This has to be done, right? And these are the few applications of linear queue. And what are the disadvantages you are going to find with the linear queue? Let us see. In linear queue, once the queue is completely full, I have taken previously 5 elements, all the 5 elements are filled. It's not possible to insert more elements. Why? Let us see this diagrammatic representation. Yes, now queue is full. Now front is pointing to this location and rear is pointing to this location, where rear equal to size minus 1 represents the queue is full, right? Now, why can't we insert the elements? Let us see. Consider the situation after deleting 2 elements from the queue. I have deleted 2 elements from this queue so that my front is at pointing to the element 4. Now, you have the space. Now, you have empty space here. But still, we are unable to perform the insertion. Why? Because in the above situation of linear queue, even though there are two empty locations, it is not possible to insert a new element as it is satisfying rare equal to size minus 1. What is the meaning of it? If the empty spaces is present in the queue also, we are unable to insert the elements in that spaces. In that places, we are unable to insert. Why? Because rare is pointing to the size minus 1. That means through rare end only we need to perform the insertion, not from the front. Right? If these locations are free also, we are unable to do the insertion. Because of that, there will be wastage of memory in the linear queues. And to avoid this, to overcome the disadvantages of linear queue, we are going with the concept called circular queue. Right? Now you may got the point why you need to study about the concept of circular queues. Right? Now let us see the definition of a circular queue. What is a circular queue is? Right? Now a circular queue is nothing but it is a collection of elements are organized in a circular fashion. If you could see here, the same thing, if I am going to connect this last to first, this becomes a circular queue. The same definition is given here. A circular queue is a collection of elements organized in a circular fashion which follows the FIFO principle. Here also it also follows the same principle FIFO. Right? And but the last position is connected back to the first position to make a circle. Instead of representing like this as a circle, we are representing in a circular form. That's all. And here when I am going to represent it in a circular form, the first 0th index will be represented with front and rear. How you are going to indicate front and rear? Front is for deleting purpose and rear is for inserting purpose. For that purpose, we require this front and rear again. Right? And circular queue ADT. Again, here we are going to use the same data, front and rear as our data values, and the operations or the same operations here we are going to perform NQ operation for inserting, DQ operation for deleting, and the last display operation for printing all the contents of the queue. And circular queue can be implemented in two ways. One is by using circular queue using arrays and another one is circular queue using linked list. Let us see how we are going to perform circular queue using arrays, and we will see the procedure for NQ operation. Right? Let us consider the circular queue size is 6, maximum size I have taken as 6. To check for everything like overflow condition, underflow conditions, everything we need to verify. For that I have taken the max size as 6. We can use size or max, any variable. Here I am taking it as max, right? And front and rear are pointing to -1, right? Where it is going to show that your circular queue is empty. Yes, see the step 1. Initially the circular queue is empty, where it is pointing, your front and rear is pointing to -1. And this is a case where you can represent your circular queue, and the front and rear are pointing to -1, so the circular queue is empty. As we have seen in the queues also, if front and rear are pointing to -1, we are making front and rear to 0, and so that from rear end we are going to insert the values, right? Let us see. Now, front and rear are pointing to the 0th location, right? And so that I am going to insert the element 10 at the 0th position. In the same way, I am going to insert one more element here. Rear is incremented and rear is pointing to 1, so that my front is at 0th position and rear is pointing to here. I am going to insert the second element, right? And rear is equal to 2, rear is incremented, and I am inserting the element 30 at index 2. In the same way, rear is incremented, rear is pointing to the same index 3, and I am going to insert the element, here, rear is pointing to 3 and I am going to insert 40 element into this location. Then rear is incremented to here and I am going to insert 50 into here. And the last one, rear is incremented to 5 and I am going to insert the element 60 into this location. Now front and rear are at these locations. Now can I directly use this rear plus plus? Can we use this rear plus plus directly to increment my rear value? If I am going to do so, then what happens? Let us see. This is a situation where you are in. Right, this is 0, 1, 2, 3, 4, 5, right. Here you are having 10, 20, 30, 40, 50 and 60. Now front is pointing to this location and rear is pointing to this location. Right, all the elements are filled. Now I am going to perform the deletion. This is my front is incremented and I don't have any element here. Now rear is pointing here. I have some space here. After deleting it, I have space here. Now I can able to I am going to perform insertion at that particular position. Suppose I want to insert some element 70. In that case, if I am going to perform rear plus plus, now what is my rear value? Rear value is 5. If I am going to perform rear plus plus means 5 plus 1. Rear plus 1 will be incremented. Rear becomes 6. Now based on this, now rear is moving to the 6th position, but we don't have 6 in this circular representation. Now where it has to move? It has to move to 0th location. Now rear has to move to 0th location so that I can perform the insertion at that 0th location. If I am going to do rear plus plus, it is not possible. Now what is the other logic we need to use? That has to perform the incrementation only, right? For that, instead of writing rear plus plus, we are going to write rear plus 1 mod max. What is the size you are going to specify? With that you need to write, and that is performing the rear value. Now let us check. Now I need to reach to 0. Rear should be reached to 0. Now what I am going to do? Now rear is at 5th position. 5 plus 1 mod. What is the max size? We have taken 6, right? 6 mod 6 is nothing but 0, right? Now I am moving my rear to this location so that I can perform the insertion of a new element 70 into this location. Like this way we are going to do the change with a rear for circular queue, right? Now in the same way, how can I check for the overflow condition here, right? If I am reaching here, if I want to insert one more element, it is not possible. That means your circular queue is full. Now what is the overflow condition we need to write? If a front equal to, here is your front value and the rear value is here. If front equal to, if your rear is going to be incremented by one value, that is rear plus 1 mod max. Rear plus 1 mod max. If this condition occurs, then it will be going for the overflow condition. Now your front is here at 1 position and rear is at 0th position. If this is the case, all will be filled. In this case, it will go for the overflow condition, right? Only this change you can find. Yes, you can see here in the function, subfunction of NQ, front equal to rear plus 1 mod max, your circular queue is full. Otherwise, if your front and rear are pointing to -1, front should be initialized and rear should be initialized to 0, and at the rear we are going to insert the element, right? And if these two cases are not there, if these two cases are not satisfied, then we are going to perform the insertion by using rear equal to rear plus 1 mod max. And if you are incremented your rear value, and we are going to insert the element from the rear end. Okay, this is your NQ operation. And if you can see the DQ operation here, step 1, here if front is pointing to this location, right? Let me represent all the front and rear values here. Yes. Now I am going to perform the DQ operation for the first time. I am going to call the function. In that case, what happens? Front will be incremented. The element which is present here is going to be deleted. That means I am unable to access that element, right? Next, if front will be incremented and pointing to the 2 value, and I am going to delete the element 20. In the same way, if I am going to move my friend value to the next location, I am going to delete the element 30. In the next case, if my friend is pointing to the index 4, so that I am going to delete the element 40. And one more. After deleting, I said you right, after deleting, if I want to perform the insertion, what happens? Yes, after deletion, I want to perform some insertion. I told you right, based on array equal to array plus 1 mod max, we are going to insert it. Through rare only we need to insert. Now, rare is pointing to this location. Previously, it is here. Now, based on the logic which we have written, now rare will be pointing to 0th location, so that we can perform the insertion. In the same way, rare will be incremented to the next locations and you can perform the insertions, right. And I am going to insert one more element at index 3, right. These are the elements where we have inserted, right. These are the element where I have inserted. Now, your circular queue is full. Now, I want to perform the deletion of, again the same statements were repeated, sorry. Yes, if I am going to delete all the elements in the circular queue, I am having only one element. If you could see the previous case which we have represented here in the D queue, one more slide. Yes, if this is the case, suppose my friend is pointing to index 5 and rare is here. If I am going to delete this one also, now where my friend is pointing to this location, right. If I am going to perform once again the DQ operation, in that case this is also going to be deleted. Now, in this case what happens? Now, friend and rare are pointing to the -1 location again. The same situation where we have seen in our queues also, right. The same thing we need to represent. But here only one difference you are going to find with the incrementation part of NQ or DQ or. There we have incremented rare equal to rare plus 1 mod max, and here in place of DQ, friend should be incremented with friend plus 1 mod max. Yes, you can see here the first case is the same, friend equal to -1 and rare equal to -1. The circular queue is empty, and in this case friend equal to rare, we are going to delete the last element present in the circular queue, and friend and rare are initialized to -1, so that your circular queue will be empty. And if other case, if I want to delete one element from the circular queue, in that case we are going to increment our friend equal to friend plus 1 mod max, right. This is how where we are going to perform the NQ and DQ operations in circular queue, and the last one is display operation. Here also, if friend equal to -1 and rare equal to -1, we are going to perform circular queue is empty. Yes, if it is not the case, we are going to display them separately, right. And here you could check here, I equal to friend, I not equal to rare, and I equal to I mod max. Here I am not increment I value plus, right. Here we are going to take same I equal to I plus 1 mod max. This will be printing all the elements in the circular queue. Suppose we have 10, 20, 30, 40, 50. The last element will not be printed. Why? Because I not equal to rare. There it is going to be stopped, right. Let us take one small example so that I can explain you this one. Here I have 0, 1, 2 and 3. Here I have the elements 10, 20, 30 and 40. This is my friend value and this is the rare value, right. Now, I equal to 0, 0 not equal to rare, rare is 3, right. Now, CQ of I, yes, it will be printing the value of 10, 10 will be printed. right? Next, I will be incremented. I becomes how much? I equal to I plus 1 mod means 0 plus 1 mod max is nothing but we have the 4 elements, right? Now, I will be incremented. I becomes 1. 1 mod 4 is nothing but 1. 1 not equal to 3. Yes, condition true again. I become, sorry, first it will be printing the value of CQ of I, that is 20 will be printed. After that, I will be incremented. I becomes 2, right? I equal to 2, 2 not equal to 3. Yes, condition true again. Now, it is going to print CQ of I. CQ of I is nothing but this value, 30 is also going to be printed. Now, your I value is incremented. I becomes 3, right? 3 not equal to 3. Here the condition fails. Previously it is true, so that it is printing all the elements. So that it will be coming out of the loop. Now, but your I value is how much? 3. Your I value is updated, but we are unable to print the value because the condition is failed. Because of that, you come out of the loop. You come out of the loop, you print once again. You print once again the circular queue. So that it will be printing, your I value is already updated, so that it will be printing the value of 40. That means twice we need to write the print statement. This will be, this one will be printed based on the condition is true. This one will be printed after the condition fails also. Why? Because I value is already updated. Okay. This is how where we are going to perform the display operation. This is a small chain we are going to find with the circular queue display, right? And in this session, in the summary, let us see what we have discussed in this session. We have seen the applications of linear queue, disadvantages of linear queue, definition, and the circular queue ADT. That means by using circular queue ADT, the implementation part also we have. See the implementation part in the next session, and if you have any doubts, please do comment in the comment section. Thank you.